Okay, so while I'm setting up this here, let's start by saying that this is going to be a video about chemical bonding and chemical bonds. So where I'll begin here is with the question of why would atoms even want to bond at all. This really comes down to two reasons. One, it's going to allow the atoms to become more stable in their electron configuration. So if you remember from previous weeks when we talked about electrons and where they are, so if we look specifically at carbon here, right, a carbon would like to have another 1, 2, 3, 4 electrons here. And so to get those electrons, what it's going to do, right, it's going to bond. It's going to find some way to get them. Right, if you notice, that electron configuration with all those electrons in there looks very similar to neon down here. And really, that's what they're going for. Atoms want to have that full configuration, right? That full outer shell, so that they are more stable. Right, the second reason is it allows the atoms to reduce the repulsive forces and remain at low energy. Right, they're always looking to get to a low energy state. So this diagram, right, it's a little crazy looking. There's a lot going on here, but I'm going to break this down. The main part of the diagram, what we're looking at, is that in the center here, right, this is for a covalent bond, we have what are called bonding orbitals. And if you take a look, right, if these are the individual orbitals for the elements on the edges, right, carbon over here, oxygen over here, if you look at where the atom's original orbitals sit, right, energy-wise, if you look in the center here, the energy actually goes down, right, on both sides, on carbon side by quite a bit. So looking at the bonding orbitals here, right, they are sitting at lower energy, which means that when these two elements form a bond, right, they're going to create a stable molecule that is at a lower energy state, which is where they want to be. All right, and this right here, carbon monoxide, it has a very stable bond. It's a very strong carbon-oxygen bond, and it's quite stable. So that is the second reason why atoms would want to bond, is to get to a lower energy state and become more stable, to minimize those repulsive forces like electron-electron repulsion. So the three main types of chemical bonds that we are going to talk about today are ionic bonds, which are bonds between metals and nonmetals, covalent bonds, which are just between nonmetals, and then metallic bonds, as you might guess, are between metals. So we'll start here with ionic bonding, and this is going to be a bond, like I said, formed between a metal cation and non-metal anion. Hopefully those words are not unfamiliar to you by this point. What this bond is normally described as is an electrostatic interaction that results because of one atom losing electrons, right, to form the positive ion, and the other atom gaining electrons to form the negative ion, right? And so this type of bond formed between two atoms with large differences in electronegativity. So hopefully you remember that word from when we were talking about periodic trends. It's the ability of an atom to pull electrons towards itself in a bond. And now that we're talking about bonding, we're going to bring it back up. And so when there's a large difference, right, one atom doesn't want to hold on to electrons very strongly. One atom wants to take them very strongly when in a bond. So you're going to have one that's basically removing an electron or electrons from the other. To represent this in a visual way, hopefully you can see it a little better here. All right, sodium chloride over here, sodium, it's got its one valence electron here. Chlorine with its seven valence electrons. Right, chlorine's essentially going to take that electron away from sodium. Right, notice the charges over here. We've got a plus, we've got a minus, and this one electron, right, I kind of circled it, is moving from sodium to chlorine. And then what happens is once these have their charges on them, just like two magnets, right, with opposite poles, they're going to attract each other, right? I'll draw this arrow kind of like this, right? I guess I should have drawn two arrows. All right, they're going to attract each other. They're going to want to be close to each other because you've got positive, you've got negative, and they're going to have an electrostatic interaction between them. So some general properties of ionic substances, right? Things that have ionic bonds in them. They tend to be brittle, which means that they will shatter when they are struck. They usually have very high melting points, right? So the melting point of sodium chloride, which we just looked at, and for those of you who are not familiar with that chemical name, that is regular table salt like you would find in your kitchen. So that has a melting point of 801 degrees Celsius, which I can assure you that is quite hot. Most ionic substances will dissolve in water, and when they dissolve in water, they become what are called electrolytes, right? And an electrolyte, all that is, it's a substance that when it is dissolved in water, forms a solution that will conduct electricity, right? Electrolytes, electricity, makes sense. Turns out it is also what plants crave. Covalent bonding. This is formed between two nonmetals. It is generally described as the result of atoms sharing electrons between them. It occurs between atoms with medium to low, or sometimes even no electronegativity difference, right? A lot of times when you will see two elements bonded together, if you remember me talking about diatomic elements, there is a list in your periodic table packet. These, right, they're the same element bonded together covalently. They have no electronegativity difference because they are the same element. There are two types of covalent bonds, polar and nonpolar. These are based on differences in electronegativity between the atoms in the bond. We'll talk more about them in the next video. And then in covalent bonding, you can form multiple bonds between the same atoms, right? So there can be more than one bond between the same atom. When we looked at that diagram for carbon monoxide earlier, if you notice down on the bottom, there was something that said bond order 3. That basically means that there is a triple bond, or that there are 3 individual covalent bonds between that one carbon and one oxygen. So covalent bonds, you can form multiple bonds between the same atoms. So here is that diagram again. I guess I didn't have to have you remember that because there it is right there, bond order 3. That means that there are 3 bonds. Usually when you see this represented, you'll see carbon, oxygen, and 3 lines across for a triple bond. All right, or in the case of water here, O and H, essentially you would just write one line between them, and that's how you represent a covalent bond when you are drawing molecules. We'll talk about drawing molecules in another week or two. But here is a representation of sharing some electrons, right? So here, hydrogen got its own electrons, oxygen got its own electrons, but, right, they want to bond to reduce that energy, get themselves to a low energy state, make themselves very stable, right? Oxygen wants to fill its outer shell, so does hydrogen. And so what happens is they share some electrons, right? And this diagram shows them overlapping between the two elements, which is more or less what happens when things bond covalently. So some general properties of covalent substances, like it says there, spoiler alert, basically this is going to be the opposite of ionic. They tend to not be brittle, right? They will deform rather than shatter when struck, tend to have low melting points relatively. All right, the melting point of sugar, right, table sugar, sucrose, 186 Celsius. All right, so a long way away from that 801 Celsius that was sodium chloride's melting point. Many of them will not dissolve in water. This depends on the polarity of the molecule, which we'll talk about in the next video, like I said. And when they dissolve, they are not electrolytes. So covalent substances will not become electrolytes when they dissolve, and many of them will not dissolve. Just think about if you've ever tried to dissolve a candle in a glass of water. Just really won't work. Okay, so the last one, metallic bonding, formed between, yes, metals. And this type of bond is a little bit different than the other two. It is described generally as a sea of freely moving or delocalized electrons that surround cation kernels. Like I said here, though perhaps islands might be a better term if you are describing the electrons as a sea, but you know, nobody asked me, so this is what we end up with. Some visuals. Okay, metallic bonding. These are both representing the same thing, right? Over here on the left, you can see that really represented, the electrons are not particularly associated or not really in the same spot. And what this is representing is that basically, right, because if you think about electrons, right, we don't really know exactly where they are, and so we generally represent electrons, especially in a metal, just kind of as a big cloud that is over all of these positive ions here that are making up the other part of this metallic bond. And so hopefully a lot of you are familiar with the properties of metallic substances. Reaching the age that you are, you probably have encountered some metals. Hopefully you know that they are malleable, which means that they can be deformed and shaped. Think about things like gold leaf or aluminum foil, right? That is quite a bit of shaping going on there. They're ductile, which means that they can be pulled down into thin wires. They are lustrous, which basically just means they're shiny. Are generally very good conductors of both heat and electricity. They do have a wide range of melting points though. All right, so gallium, right, that melts 29.76 Celsius, which is not all that warm. Basically, you can melt gallium in the palm of your hand, while tungsten melts at 3,422 Celsius, which is a rather high temperature. As you probably also know, metals tend to not dissolve in water. So the basic takeaways here, things to remember about these three bond types, right? Ionic bonds form between metals and nonmetals. Electrons are given and taken. Covalent bonds form between just nonmetals. Electrons are shared. Metallic bonds form between, well, metals. And that the free electrons are surrounding metal cations, right? The other things that you want to remember that I did not put up here, that atoms are bonding to reduce their overall energy, get to the lowest energy state, and that they are sharing / giving up and taking electrons really to get to a stable electron configuration. And so that is the basics of bonding, and I will see you in class.